Okay, now this is officially section 5.4 and we are solving right triangles. In those right triangles, in this particular case, I have triangle ABC. I have side A at being 44.25 centimeters, side B at 55.87 centimeters, and I need to then find side C. I have to find angle A, and I have to find angle B. The very first thing I'm going to do is I'm going to use Pythagorean theorem to be able to find the hypotenuse C. And the hypotenuse C would of course be equal to the square root of A squared plus B squared. C therefore is the square root of 55.87 squared plus 44.25 squared. And when I run that through, I find C is approximately, with a decimal here, approximation of 71.27. So 71.27. And I'm using 4 significant digits, because in my sides that I were originally given, there were 4 significant digits. Well, that's great, and I have 3 sides, but I don't have any of the angle measure. Well, let's take a look though, and we'll use angle A. Using angle A, I know that the tangent of A must equal the side opposite over the adjacent. The side opposite over the adjacent. And I'm using that specifically because I was definitely given a angle, or side A and side B, and I haven't done any kind of mathematics, trig, whatever, Pythagorean theorem to make an error. So I know that the side of 45.25 divided by 55.87. In other words, if I were to take the tangent of angle A, it would equal 44.25 divided by 55.87. So I'm going to go to my calculator here, and this is where I want to use the inverse trig. Of course, my calculator wants to give me things twice, even though I'm clicking once. And it is 44.25 divided by 55.87, and I'm going to then close my parenthesis. When I hit enter, it's going to tell me that the angle theta A is 38.38, rounding to 4 significant digits, degrees. That's angle A. So therefore, angle B must therefore be 90 minus 38.38 degrees, and I'll therefore find that B is 51.62 degrees. So now I've solved the entire triangle. I know every side and I know every angle. Okay, here we are solving a problem that's called the angle of depression. And here's a little picture of the angle of depression from the top of a tree to a point on the ground, 15.5 meters from the base of the tree, is 60.4 degrees. From that, I should be able to find the height of the tree. The measure of angle B here, equals the measure of the angle of depression here. And the reason is because the two angles are called alternate interior angles. In other words, this line is parallel with this line, and the line goes between them, so the alternate interior angles must be the same. So I know that B is 60.4 degrees. Write that a little bit better. 60.4 degrees. I then can use my trig functions to be able to solve for B. I want B. I don't have my hypotenuse of this triangle. The only thing that I have is the side that is adjacent to my angle. And I want to know the side that's opposite. Because I want the opposite side, I know the adjacent side, then I'm going to use the tangent function because the tangent of theta is the side opposite over the adjacent. So I'm using what I know. So tangent of 60 degrees, I always want to say 60 degrees, sorry, 60.4 degrees is equal to the side opposite, in this case B, divided by the adjacent side, and the adjacent side is 15.5. So I now know that 15.5 times the tangent of 60.4 degrees is equal to B, because I just multiplied the entire equation by 15.5 to rid myself of that fraction and solve for B. Once I run that through the calculator, I find B is approximately 27.3 meters. That means that tree is about 27.3 meters tall. Here's another problem that's an angle of depression. Find the angle of depression from the top of a 97-foot building to the base of the building across the street located 42 feet away. Because that these are alternate interior angles, I know that angle B is this angle would be equal to the angle of depression. I also know that from angle B, I am given the adjacent side and I'm given the opposite side. Again, thinking of my 6 trig functions, if I know the opposite and the adjacent sides, that means tangent. So I could write that the tangent of angle B must equal the side opposite, which is 97, over the adjacent side, which is 42. And again, I picked tangent because I was given opposite and adjacent. Then I know that angle B is going to be the inverse of tangent of 97 over 42. And of course, once I pump that through my calculator, I find B is approximately 67 degrees. So if this is 67 degrees, alternate interior angles says that this angle of depression is also 67 degrees. Bearing. There are 2 ways that bearing is mentioned, 2 different methods. One method is when a single angle is given, such as 164 degrees. When that happens, it is understood that the bearing is measured in a clockwise direction from due north. So I have my due north here on the board, and I want to go 164 degrees. Now, we're taking this out of the context of I have my XY, my initial side being at X. Your initial side is no longer at the X-axis. Your initial side, when you're dealing with bearing, you're starting at due north, and you're going to now measure in a clockwise direction from due north. So from due north, I'm measuring this way, 164 64 degrees. That's what bearing means. The second method of bearing says that the bearing will be expressed as an acute angle again less than 90, from the north-south line. And when it does this, it's going to give direction as either east or west from this line. So for example, they could say the bearing is 25 degrees, but when they say 25 degrees, they would give you north 25 degrees east. So you have to know that north, south, this is east, this is west, and we're going to start at the north, and we're going to go 25 degrees to the direction of east. So I'm going to have this being my bearing. If it said south 47 degrees west, I would start from the south, and I'm going to rotate towards the west, and I'm going to rotate 47 degrees. So two methods, one starting at due north and measuring clockwise, the other method from the north-south line, and it would say north 25 degrees east, south 47 degrees west. It could say north 80 degrees west. It could say south 15 degrees east. And that's going to tell me where I'm beginning and the direction in which I'm rotating in my bearing. That's going to be critical for setting up these particular problems on bearing. This problem, and I have a drawing here for you. You won't always be given the drawing. You're going to have to probably create your own drawing. Radar stations A and B. Here's my radar stations A and B. A and B are on an east-west line. So I've got a line here from A to B. This is my east-west line. And it tells me those two stations are 8.6 kilometers apart. I have that distance marked. Station A detects a plane at point C, and it's on a bearing of 53 degrees. So I'm going to be at point A because my bearing was given just with degrees. I'm going to start at due north. I'm going to rotate clockwise 53 degrees, and that's where my plane is with a bearing to point C. Simultaneously, Station B detects the same plane on a bearing of 323 degrees. Well, I'm going to now be at B, and again, it's only given 323 degrees. There's not north, south, east, whatever. It just says 323 degrees. So again, I'm going to start at due north. I'm then going to rotate clockwise 323 degrees. Well, 323 degrees then, I know that to do a full rotation back to north would give me 37 degrees. Because that's 37 degrees, these make a right angle because this 8.6 was a northwest, an east-west line. I know that this has to be, since it's 37, this angle has to be 53. Also, alternate interior angles shows me over here that angle A must be 37 degrees. Now that I have my whole entire triangle set up and I have things labeled, I want to know the distance from B to C. I want to know the distance from B to C. In other words, I want to know A. Well, again, I'm going to use my trig functions, and I'm going to think about if I'm at angle B, and the thing that I know is that the adjacent, the opposite, I know some of these things. What is what in this triangle? And if I'm at angle B and I want to know A, A is the side that is adjacent. The thing that I know is the hypotenuse, and the hypotenuse is 8.6. So I'm going to choose to use the cosine. The cosine of 53 degrees is my side adjacent, in this case A, divided by the hypotenuse, which is 8.6. That allows me to find the distance between B and C. Solving this, I know that A is equal to 8.6 times the cosine of 53 degrees. Once you pump that through the calculator, you'll find that A is approximately 5.2 kilometers, and kilometers is the unit that we have our measurements in. Here's another bearing problem. I'm going to blow this up a little bit. This one uses the second method of bearings. A ship leaves a port and sails on a bearing of south 34 degrees west for 2.5 hours. It then turns and sails on a bearing of north 54 degrees west for 3 hours. Now you're truly beginning to understand that you need to know how to do bearing and which method to use. If the ship's rate of speed is 18 knots, that's nautical miles per hour, find the distance from the ship is from the port. Well, this drawing here shows that we're going to start, here's my ship at port, we're going to call that A. The ship leaves the port and sails at a bearing of 34 degrees west. So here I am at my port A. My north-south line is here. It says from the north-south line, from the south, I'm going to go 34 degrees to the west. So 34 degrees to the west. And that's the bearing at which this ship is sailing. That ship sails along that course for 3 hours. After 3 hours, the ship's then turn, or 2.5 hours, I'm sorry, then the ship turns. Here we're at point C. The ship then makes a turn. The bearing is north 56 degrees west. So here's my north-south line. I'm at north. I'm going to then go 56 degrees west. I'm going to turn. My ship is then traveling at that bearing until it arrives at point B, which is 3 hours later. So I have my sketch of what my ship has traveled. The thing I have not put yet on that is the distances. But I can quickly get the distances because it tells me that it traveled for 25 hours or 2.5 hours, and it traveled 18 knots. Well, 18 knots times 2.5 hours is equal to 45, and that's nautical miles. So I know that B is 45. I also can find C because it told me that it traveled for 3 hours, and of course 18 times 3 is 54, and that again is in nautical miles. So I know A is 54. I want to know the distance the ship is from the port. Well, the ship from the port This is where the ship started. It traveled, and it's right now at B. So I want to know this distance C. The fastest way then to solve this is simply by using the Pythagorean theorem. And the reason I know I can use Pythagorean theorem is because that this is a right triangle. Angle C is a right triangle. 34 and 56 is in fact 90. And again, I use the fact that I have parallel lines, and if this is 34, this is 34 by alternate interior angles. 34 plus 56 is 90. So therefore, C is the hypotenuse. With C being the hypotenuse, I then know C is equal to the square root of 45 squared plus 54 squared, and you pump that through your calculator and you'll find that C is approximately 70. So that ship is approximately 70 nautical miles from the port. Those are some real good examples of how you'll be using trig to solve right triangle trig problems. Again, we'll be meeting on Tuesday and Thursday at 10:30 in C122. And again, we will practice solving right triangles when I see you on Tuesday after spring break.